Hi there, I have an integral problem for you, and let's see how we can evaluate it. So first of all, secant is just 1 over cosine. So let's substitute, let's just say this is 1 over cosine for all of the secants and see what do we get. So, so this secant is just going to be cosine at the denominator. For example, this one, 2 plus 1 over cosine, so this will be 2 cosine plus 1 on this part, 2 cosine x plus 1, and cosine again here, so this is cosine squared. And for this thing, so this is 1 over 1 plus 2 over cosine, so cosine x plus 2 squared here, cosine x plus 2 squared here, and so at the denominator it has cosine squared. It will cancel with this one, so imagine there is cosine squared here, and these two will just simplify. So I'm gonna get okay, let's just write it here. So it will be 2 cosine x plus 1 over cosine x plus 2 squared. Okay, cool. It's more or less same complexity. Okay, but this will be more helpful. So, well, ideally, I want to get rid of this squared. I just want to, simplify it. Maybe I can try to separate this thing as two sums. Okay, and so, well, I know that one in trigonometric integrals, I mean, this may not just be 1, but maybe this will be a cosine squared plus sine squared. Here, why is it useful? Because if I say this, and so think about the first part with cosine and this, okay, when I take it into cosine parentheses, I will get cosine x plus 2 and it will simplify with this one. So it will actually be nice. So if I do that, so like I said, from I'm just going to separate it as two sums. So the first one will just be cosine x parentheses, this thing over that thing squared. So it will just be cosine x plus 2, okay, dx. I'm just separating them. And so for the second one, this is just sine squared over that thing. I can't do much about this one yet. Sine squared x over cosine x plus 2 squared. Okay, so previously again on this channel, I made a video how to solve trigonometric integrals with the substitution u is equal to tangent x over 2. And this substitution actually works for both of these integrals. For example, for the first one, first you just need to add and subtract 2 and then separate and then use. Well, you can use it, but we're gonna do actually there's a nicer way to solve this specific example. Okay, but that way works. So let's try to do integration by parts on this thing. Okay, so I'm just gonna do DI method, which is the fastest way to do it. So of course, well, I can integrate 1 over cosine x plus 2, but I don't want to do that. So let's just differentiate this thing. And if I'm just going to integrate cosine x. So if I differentiate this thing, first one's derivative times this, first time minus derivative of this thing, derivative of cosine is just minus sine, so it will be minus positive. So it's just sine x over cosine x plus 2 squared. Okay, cool. And integral of cosine is just sine. So this will be this, so this is plus minus. So this integral, so I said this is the first integral. Okay, let's say this is I1 plus I2. This is my initial, this is my last call. And so I find that I1, the first integral, is equal to cosine x plus 2 sine x. Sine x. Oh, sorry, it's 1 over cosine x plus 2. Let's just delete this thing. Okay. Sine x over. I made this mistake also when I was solving. I don't know. I just don't learn from my mistakes. And so for this one, it will be minus integral. Well, since it's vertical, horizontal, I'm just doing with integral. So it will be sine squared x over cosine x plus 2 squared dx. Well, this looks familiar. Well, so this is actually equal to I2. So actually, and I needed I1 plus I2. I can just send this thing to the left side. So I'm just gonna get I1 plus I2 is equal to sine x over cosine x plus 2. So we magically got the result, and this is actually our answer. And that's the end of it.